Welcome to the course on power quality, and we will like to discuss today control of unified power quality compensators. We have a control technique based on two classification. One is time domain control algorithms, which are typically like a famous algorithm have been synchronous reference frame theory, also known DQ theory. Then unit template or PI controller based theory, then instance reactive power theory, also known PQ theory or alpha beta theory, then instance symmetrical component theory, then neural network theory, window drive LMS algorithms, and single phase PQ theory, single phase DQ theory, then enhanced phase lock loop based control algorithm, then adaptive detective algorithm, also known as typically adaptive interference cancelling theory, and many more. There are plenty of algorithms which are available and are used for this, typically for the control of UPQC. Like these are time domain control algorithm. There is another set of algorithm which we call it frequency domain algorithm. They work like a Fourier series theory, then discrete Fourier transform theory, then fast Fourier theory, recursive discrete Fourier transform theory, Kalman filter based control theory, wavelet transform bit theory, and Stockwell transform S transform theory, the empirical decomposition transformation theory, and Hilbert-Huang transformation theory, and many more. Like so, there are so many control algorithms which can be used for this UPQC. And coming to, let us say, control of UPQC as a UPQC Q, or control of UPQC as a UPQC P, which we discussed in previous lecture, and control of UPQC S. Like well, coming to UPQC Q, in this mode a DVR is used mainly for reactive power injection for fundamental voltage compensation. In UPQC mode of operation, the DVR cannot compensate for voltage swell, and it is considered that the D-STATCOM is compensating the reactive power of the this consumer load. Of course, at unity power factor is realized at PCC, and total reactive power of the system is compensated by the D-STATCOM. Moreover, DVR is injecting a voltage at the quadrature with the AC mains current, and in case of voltage sag, compensation is there is a limitations of sag compensation depending upon the voltage rating of the DVR. These are typically you can think about in UPQC Q that in a right hand UPQC means D-STATCOM on right hand. So, it can do sag compensation, but it cannot do swell compensation. As you can see here, it is not cutting, it is not possible like in case of. So, this is the limitation for this control algorithm, that we cannot compensate the swell in this case, like also. And the rating as far as for voltage sag compensation, you can calculate the load voltage minus the under root this VLC square minus DVR square upon VLC, that is the kind of per unit voltage sag can be expressed, which we can compensate depending upon the rating of the DVR, and X is the percentage of voltage sag for the compensation, and VDR is the injected voltage by the DVR, and VLC is the load voltage of the compensation. Normally, it is rated for load voltage or the rated PCC voltage. So, rating calculation for both DVR and D-STATCOM may be done from phasor diagram as follows. So, the injected voltage by the DVR is now VLC square minus VS square under root of that is the because we are injecting at the quadrature, that is the relation comes for V injected voltage, and V rating of the DVR comes equal to V injected into IS, that becomes VS IL cos phi into tan delta, like, and where the IS and IL the source and load current, and cos phi is the load power factor, and delta is the angle between the load voltage and the PCC voltage after the compensation, which we usually call like a kind of power angle or so, and that can be equated under root VLC square minus VSC square under root of that divided by the VS, like and the D-STATCOM current rating can be like I D-STATCOM IL under root 1 minus X square plus cos square phi minus 2 cos phi minus delta, and 1 minus X divided by 1 minus X. So, that is the rating of typically of D-STATCOM in terms of load current rating, and the V rating of D-STATCOM is VLC IST. So, you can keep the value of IST, and this is the typical rating of V rating of the D-STATCOM, and therefore, total rating will be IS U PQC will be equal to SDVR plus SDST, like So, coming to this control of UPQC as a UPQCP, in UPQCP the DVR inject the minimum voltage for the condition of voltage sag and swell, and in this mode DVR inject the total active power for the voltage injection of series compensation. In this case, the series voltage is injected in phase with the AC mains current or PCC voltage, thus requiring only active power which can be received by the D STATCOM through DC bus. It increases the current rating and the thus kV rating of D STATCOM. However, the kV rating of DVR is minimum in this operating mode of UPQC and UPQCQ, and moreover the DVR can compensate for voltage sag and voltage swell in this UPQCP mode of operation. Well, this is the how we are going to compensate typically, I mean like a voltage sag. So, we are typically injecting the voltage by DVR in phase with the current. So, that is, and in case of swell we are just putting the voltage opposite typically in series. So, that virtually you can call it like a, here it consume the power, it's release the power and which goes circulate through D STATCOM like and the rating can be very simplified calculated as per unit VLC minus Vs upon VLC, and that is V injected by VLC in per unit. And this UPQCP mode of operation of UPQC require minimum injection voltage, thus minimum rating of DVR, but at the expense of D STATCOM rating, which increases due to large active power flow through the D STATCOM. And the rating calculation for DVR and D STATCOM may be done from the phase diagram, and the injected voltage VLC into VLLC X, and the V rating of DVR is V injected IS, VLC minus Vs into IL cos phi. So, it becomes VLC into X into IL cos phi, and the D STATCOM rating, because you just put the active power here. So, that is the reason it goes to IL square minus I square under root plus XL cos phi square like, and the V rating of D STATCOM is VL as IL as DST. So, you can keep the value of DST. So, that gives the rating of D STATCOM, and the total rating of UPQC comes like S is equal to S DVR plus S DST STATCOM. So, coming to as a control of UPQC as a UPQCS, the control approach of UPQCS has been featured as most generalized one with number of objectives. The overall V rating of both D STATCOM and DVR, overall minimum rating, which consists the rating of DVR and D STATCOM, on utilization of DVR rating with reduced burden on D STATCOM, on optimum sharing of rating between the DVR and D STATCOM. So, in UPQC the DVR may inject the voltage both in both the condition of voltage sag and swell, and in this UPQCS mode of operation of UPQC, the D STATCOM is normally used for all current based compensation other than full reactive power of the system. And in this case, DVR inject a voltage in series between AC main and the load end at predetermined phase angle with the PCC voltage, and DVR needs both active power and reactive power through DVR. So, this concept of UPQS with phase angle control of series voltage injection of DVR has been perceived very recently in four different objectives, and this is the typical phasor diagram for UPQCS. So, here you can see the voltage sag. So, we are injecting the voltage, of course, which is not in either phase with the current or quadrature in the current. So, you might be injecting the active as well as reactive power, and this is for the voltage swell. Again, we are injecting the voltage to reduce the swell at the point of common coupling. That voltage is also injected neither in phase with the current nor typically at the quadrature of the current. So, that is typically, so part of the reactive power even we transfer to the DVR in this case like, and this is the typically phase current based representation of voltage sag compensation. So, you can just see earlier it is the let us say voltage, but once sag comes you inject the voltage here by DVR, and that is the new voltage which across the load. And of course, when you really have this voltage goes up in a sense, in that case you will find with respect to the load voltage, the source current becomes in phase with the source voltage, because you want to have a D STATCOM. So, even the partly the rating of the D STATCOM is also reduced in that case, and that load is virtually transferred partly by the for the DVR like. So, the voltage injected by the DVR is rated at voltage V DVR equal to VR and the angle, and your phi DVR at which the voltage injected can be calculated phi DR as a pi minus cos inverse V square plus VDV square plus VLC square divided by 2 SVR. So, we calculate this angle virtually this of at which we are injecting. So, this is the angle at which we are injecting, and from this typically from this triangle we calculate this relation like for calculation of this angle like also. And the active power of the DVR we can calculate V DVR IVR, and this angle between the two which phi DVR we just calculated. The reactive power of the DVR can be your Q V DVR, I DVR and psi phi DVR like. So, this condition of DVR is considered for the compensation by the DVR with minimum active power and maximum reactive power full utilization of its rating as V DVR equal to VR. And the V rating of DVR is S DVR equal to V DVR and IS like. And let the delta be the angle between the load voltage VL and PCC voltage Vs after the compensation. It can be calculated as delta equal to sine inverse Vs V DVR sin phi dr divided by VL, because that is the angle between the typically V DVR and VL, and the angle beta between the PCC voltage and the consumer load current after the compensation comes beta equal to phi minus delta. So, you can consider that compared to phi, now this angle is reduced, and it means the part of reactive power is compensated by the typically of DVR, and D statcom rating can be calculated now IS DST IL sin beta square plus IL cos beta minus cos phi, and typically divided by 1 minus x like and the angle phi DST between the D statcom current and PCC voltage can be calculated from this pi by 2 plus tan inverse cos beta minus cos phi upon 1 minus x divided by 1 sin beta, and the active power of the D statcom R as P D statcom VL IS DST cos phi DST like, and the reactive power of the D statcom can be phi DST VL I DST sin phi DST, and the SDR VL into I DST, and therefore, the total V rating of UPQC is the sum of SDVR plus SDST like. So, this condition of UPS reduces the burden on D statcom rating at some part of the reactive power of the load is supplied by the DVR as the angle is shifted like. Well, this is a typical control algorithm, I mean for using, you can call it synchronous reference frame theory. So, typically this is the control of DVR part. So, we are sensing the voltage and converting with the and sensing the current from which we are getting cos theta sin theta. So, we use for synchronous reference theory. So, we may get even because of voltage unbalance also ripple here. So, we have to pass on through, you can call it like typically through low pass filter to get DC component, and similarly we have a here again the voltage regulation. So, that give us about typically about the a voltage component corresponding to the reactive power for voltage regulation or control, and VDVQ with the again with the cos theta sin theta we convert to the load voltage, I mean that is regulated voltage, and we have a feedback voltage. So, that gives the getting signal for the your series compensator or the DVR devices, I mean which are in a part of the inverter. And coming to D statcom control, I mean here we are taking again load current and putting a again DQ transformation, and then using low pass filter we take a here the component corresponding to which active component, and we take typically of you can call it DC link voltage control, because you have to regulate the DC link voltage similar to like a D statcom. So, that you add it, and then with this with cos theta sin theta which are obtained from PLL of voltage. So, you have a typically like a reference current grid current calculation, you have a sense grid current and 0 sequence neutral current, you keep the 0, you give the getting signal for 4 devices here for this. So, this is 4 leg D statcom part, and this is your, but the more important part here the angle is calculated from the voltage PCC voltage, and here your angle is calculated from the current. So, this is the basic difference for that, and this is typically you can call it voltage control which we discussed earlier, and here it is typically the current control. So, D statcom operates in current control, and your typically the DVR operates in voltage control mode like. That is about the typically of control of. The objective of D statcom is to enhance the power quality of the supply current as well as to support the common DC bus voltage of D statcom, and DVR is absorbing the active power by the D statcom. And coming to these equations of this algorithm, so load current in the 3 phases are converted to typically into DQ reference frame, then where the theta is the angle which calculated from the current, and DQ axis of course we have consist of DC and AC component. So, by using low pass filter we take only DC component part of it, and that we call it like we extract IL DIQ, that is corresponding to fundamental current like. And DC link voltage control we put like a reference voltage, and we use the PI controller, I mean to regulate the voltage, and which we consider the loss component as in case of the D statcom, and this is typically the error, and this is the typically the PI controller equation for calculating the loss component for regulating the DC link voltage of the typically of DVR. And the amplitude of direct axis and quadrature axis, you can call it direct axis is I loss plus this load active component of current, and quadrature we keep 0 because you want to have a unity power factor, and the 0 sequence we keep it 0 because you do not have a 0 sequence current flowing into the grid like. So, for unity power factor operation, the reference current must be in phase with the voltage at the PCC with no 0 sequence current, therefore, IQ and I0 are kept 0, and this is typically you can call it after getting IDIQ you can transform to reference grid current, typically balance theory from this inverse spark transformation. And similarly, you can have for control of DVR that we sense typically the grid voltage. So, we convert DQ voltage by this again spark transformation, and typically again by this we have a DC component, AC component. DC component is corresponding to fundamental voltage, and AC component is corresponding to like a negative sequence or harmonics or so. Harmonics and oscillator component are these AC and are eliminated by low pass filter, and the amplitude of your AC load voltage is a control with the reference of VL using a PI controller at the output, and you say injected voltage corresponding to we calculate corresponding to this voltage controller, where this is the error is a reference load voltage and this is the feedback estimated voltage. And the direct access component we can calculate, it is a DC component of, and the quadrature typically the corresponding to the PI controller as well as those supply voltage, and that is 0 sequence is 0. And once we get VDQ, we apply the inverse transformation where theta is calculated from the PLL from the current. So, we get the load voltage, and this load voltage with the sense load voltage we put the PLL. So, that is complete the one kind of control, the simplest control of your SRF theory for the typically for this UPQC. Like coming to modeling, simulation and performance of UPQC. So, this is the typical case performance of UPQC at critical load for neutral compression, load balancing and regulation of load during the voltage sag compensation. So, you can see clearly here it is a supply voltage, here it is a voltage sag, and corresponding to voltage sag certainly for same power which load is drawing, because load power remain constant. So, you will find the current is increasing, supply current is increasing, but it is balance and sinusoidal here, and here part of the one phase load is reduced, that is the reason current is reduced, and here you can call it another, typically the voltage comes normal, so current reduces, and here again another phase load is reduced, then you get the current in the supply further lower, and then it comes to a normal condition from where it started, and you can clearly see the load voltage remain regulated, sinusoidal and balance across the load, but the load current you can call it is a lagging power factor load. Here it was two phase load and single phase load. So, load unbalancing, neutral current compensation all are taken care, and these are of course D-STATCOM current, and this is the load neutral current, and this is the D-STATCOM fourth lag neutral current. This is the source neutral current which is regulated 0, and the DC link voltage regulated well, and this is the DVR voltage. When voltage sag is there, it is injected, that is why the load voltage is maintained regulated. So, it is providing the compensation, keeping a load voltage, sinusoidal balance and the grid current balance, but the grid current magnitude will change at because it is on the supply side for deriving the constant power to the load like. So, performance of UPQC at critical load and neutral component load balancing and regulation. We have already discussed about this, what the typically the voltage sag have been then, load voltage is regulated constant, and it is observed that only voltage sag voltage is injected by DVR to regulate the load voltage, and due to sag in supply the increment in supply current is observed, and the load is changed from two phase and single phase. So, these are applied again back to. So, it is observed that supply current are balanced and are in phase with the supply voltage even unbalanced load supply, and the load neutral current is supplied by fourth lag of D-STATCOM, and the supply neutral current is approximately 0 with all operating conditions. This is another case when we have a voltage swell, like the UPQC performance. So, you can see here from here to here there is a voltage swell, from nominal it is going to be little higher, and because of same power that is why current is going to down, but here one phase load is reduced, so current reduces further, and here the voltage comes normal, but current have to increase typically slightly, and here another phase load is reduced, so current further reduces on supply, but supply current are balanced and sinusoidal, and load voltage is regulated across the load, and that is why load current are not affected even the voltage swell here, but here two phase load, single phase load, and again back to, and here D-STATCOM current. This is the load neutral current which is compensated by fourth lag of the D-STATCOM. This is the source neutral current maintained 0, and DC link voltage regulated to constant, and this is the DVR voltage which are injected to compensate the voltage, typically the voltage swell here, so that load voltage is regulated like. So, this is the compensation for voltage swell like. So, these are the observation that a voltage swell is applied of 0.3 per unit for 10 cycle, and you observe that load voltage is regulated at a constant amplitude under the voltage swell and nominal operating condition. It can be observed that only during swell a voltage injected by DVR portion of UPQC to regulate the load voltage, and due to swell in supply voltage a decrease in supply current is observed. And the load is changed at this time to two phase and then single phase, and these load are applied again back, and it can be observed the supply current or balance are in phase with the supply voltage even under unbalanced load, and load terminal neutral current is supplied by the fourth lag of D-STATCOM, and the supply neutral current is approximately 0 under all operating conditions. So, with this we cover typically the case study. Now, we will like to discuss the numerical examples of this UPQC like. So, coming to the first numerical example, a single phase UPQC, a unified power quality compensator consisting of D STATCOM and DVR using 2 voltage source converter with common DC bus capacitor is to be designed for a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor as a right hand UPQC Q, and there is a voltage sag of -20% in the supply system with base voltage of 230 volt. Calculate the voltage rating of the DVR of UPQC Q, the current rating of UPQC Q, the V rating of DVR of UPQC Q, the voltage rating of D STATCOM of UPQC Q, and the current rating of D STATCOM of UPQC Q, the V rating of D STATCOM of UPQC Q, and the total V rating of the UPQC to provide reactive power compensation of load for unity power factor at means constant regulatory voltage of 230 50 hertz across the load. So, this is the typically the condition where voltage sag is applied, because it is a UPQC Q. So, there was a voltage sag, the voltage is reduced from 230 volt to 184, I mean typically, but that much voltage we have to inject like a VDVR equal to after, and this is the new voltage typically in this. So, that is the concept of UPQC Q. There is no reactive power down here. So, this complete model is developed, and then these are the typically the performance result after the simulation. So, you can say supply voltage, supply current which is at unity power factor, this is the load voltage which is regulated across the load current, and this is the injected voltage by the typically to for the sag, I mean typically to compensate voltage sag from the supply to the load voltage. So, coming to numerical part of this, given that Vs equal to 230 volt, F equal to 50 hertz, a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor, and there is a voltage sag of -20% in supply system with a base of 230 volt. The active power of the load is PL equal to VL IL PF. So, this comes around 4600 watt, and the supply current during normal condition is your PL upon Vs. So, it comes 20 ampere, and during nominal grid condition the typically the voltage is 230 volt, and ID STATCOM is IL sin phi, that 25 under root 1 minus 0.8 square. So, it is a 15 ampere, and the D STATCOM rating is 230 and 15, that becomes 3450 VA. During normal grid operation the VDVR is 0, hence during the this is 0, but during the voltage sag compensation, I mean during normal condition D STATCOM is supposed to, but DVR is not supposed to because there is no voltage sag, but when voltage sag is there the DVR comes into action. So, voltage rating of UPQC is computed, there is a voltage sag of -20% in supply system with base of 230 volt, and supply voltage reduces to 230 typically of with 20% sag 184 and X is 0.2. So, we can calculate the now typically the supply current, because power is same 4600 divided by 184. So, current on the supply becomes 25 ampere, and the voltage rating of the DVR you can calculate is VL square minus VS square, because UPQC Q we are injecting at the quadrature with the current. So, that comes to 138, and current rating of UPQC is the same as the supply current, that is 25 ampere, and the V rating of UPQC is VDVR IDVR. So, we get voltage injected there which we calculated here, multiplied the current. So, it becomes 3450 VR, and PDVR is 0 because we are not taking any active power injection for the, we are injecting the voltage at the quadrature with the current. So, SDVR will be PDVR is Q square. So, that is 138 into 25. So, this is 3450. So, voltage rating of D STATCOM is equal to 230 volt, and it is connected across the load of 230 volt sine wave. So, current rating of UPQC computed typically as to correct the power factor to unity, hence the required reactive power of D STATCOM is now lower than the reactive power of the angle between the voltage and current. So, that is phi minus delta, and cos phi is the load power factor, and delta is the angle between the load voltage PC is voltage after the compression. So, that delta tan delta equal to VL square minus Vs square divided by Vs. So, it comes 0.75 at delta is 36.5, and power factor angle is also 36.5. So, D STATCOM current rating, if you put the value, it comes 0 ampere. So, D STATCOM, because whatever the reactive power required by the load, it is already compensated by the DVR. So, V rating of the D STATCOM will be 0, and typically the V rating of the this total UPQC will be D STATCOM plus DVR. So, D STATCOM 0. So, DVR takes this much T450. Hence, considering the overall rating both normal and the rating of the both compensator is typically of D STATCOM 30 under nominal condition with 15. So, this is the typical rating of D STATCOM, and DVR rating is typically 3450. So, total VA rating will be sum of both, that comes 6900 volt ampere like. So, coming to numerical example second, a single phase UPQC consists of D STATCOM and DVR using 2 VSC with common DC bus capacitor is designed for a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor at the left hand UPQC, and there is a voltage sag of 10% in the supply system with the base supply voltage of 230 volt. Calculate the voltage rating of DVR of UPQCQ, current rating of UPQCQ, VA rating of UPQCQ, the voltage rating of UPQCQ and current rating of UPQCQ, and VA rating of D STATCOM of UPQCQ and total VA rating of UPQCQ for reactive power compensation of the load for unity power factor means, and with the constant regulated voltage of 230 across the load. So, this is typically the, you can call it how we are doing the compensation. So, here we have a typically the voltage sag and we are injecting the voltage virtually of this one to compensate, but now you can say it is a typically and then these are the waveform. So, given 230 volt 50 hertz a load of 0.8 lagging power factor, there is a voltage sag of minus 10% with a 230 volt, it means the voltage reduces to typically 207 x becomes 0.1 and the load power is typically 230 into 4600 and the power your current becomes 22.22 and voltage rating of D STATCOM 230 and current rating will be corresponding to reactive power of 15. So, D STATCOM rating is typically 3450 and your DVR rating is 0 under normal condition. Now, voltage sag compensation by left hand QPQC. The voltage rating of DVR of UPQC compressor, there is a voltage sag of minus 10% in supply system with base value of 230 and therefore, DVR left must inject the voltage at quadrature with provide the load. So, VL cos phi equal to Vn and cos phi. From this relation we are able to get typically beta equal to 27.27 and delta equal to phi minus beta, that comes 36. So, angle comes 9.6 degree and from this we can calculate putting the value of beta here. So, we can find out the rating of VDVR 43.17 and the current rating of DVR same as the load rating because it is connected on the typically of series compensator on the load side, and V rating of UPQC is typically your voltage rating into current. So, this comes that much DVR and P is 0 because it is a UPQC key. So, you do not inject any active power and the SDVR will be PDVR, that is equal to 1079.29. So, that is the V rating and the voltage rating of D STATCOM of UPQC equal to the AC voltage, that is 207 because it is connected on the grid side. So, since it is connected across PCs, so it is a 207 sine wave waveform and the current rating of UPQC is computed typically as follows. The UPQC is correct to correct the power factor of the source to unity, hence the required reactive power of D STATCOM is now lower than the your load reactive power H angle of load current, that is a beta equal to phi minus delta. So, you can just calculate the D STATCOM rating from I sin phi. So, it is 11.45 and Q DST will be your VLIL sin beta. So, it comes like a 2370.18 after multiplication of this, and P DST is 0 because it is not circulating any active power because DVR does not need active power like coming. So, V rating of D STATCOM will be directly Q DST and that is typically 2370 and total rating of this during sag will be to D STATCOM rating and the DVR rating, typically it comes 3449.4 VA like. However, during normal condition D STATCOM had to supply the all reactive power of the load as its rating have to be like a 3450 and hence the considering overall rating both normal and the rating of the typically D STATCOM 230/15. So, it comes the D STATCOM rating and DVR rating voltage is this and current rating is this. So, it is a DVR rating and total rating will be the sum of both, which is sum of these two. So, it comes 4529.25 VA. So, coming to a numerical example 3, a single phase UPQC consisting of D STATCOM and DVR using 2 VSC with common DC link capacitor is to be designed for a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor at the left hand UPQC, and there is a voltage swell of 10% in the supply stream with the typically to calculate the voltage rating of the UPQC, current rating of UPQC and VA rating of the UPQC of DVR, and then the current rating of D STATCOM of UPQC, voltage rating of VA rating and the total VA rating of UPQC to provide reactive power compensation of load and unity power factor means regulated like. So, you can see here it is a D STATCOM is put on left side and DVR on right side, and accordingly how the voltage injection is taking place. So, after making the model it is coming typically the waveform. So, coming to numerical part of this, given that Vs equal to 230 volt at 50 hertz, a load of 230 volt 50 hertz 25 ampere and 0.8 lagging power factor, and during nominal grid condition the voltage is 230 and the statcom supplying reactive power. So, that comes your at 0.8 power factor of 25 ampere, it comes 15 ampere. So, the statcom rating is 230 into 15. So, it becomes 3450 V, and the rating of DVR we said is 0 volt, and the VA rating of DVR in the normal condition, and active power load you can find out typically 4600. So, that is under normal condition. Now, coming to voltage swell compensation by left hand UPQC, there is a voltage swell of 10% in the supply with the voltage of 230. It means during voltage swell the supply voltage increases typically of to 253, and supply current during the voltage swell compensation is typically the current on supply will be your active power force of the load 4600 divided by 253. So, current becomes 18.18, and the voltage rating of the DVR from we can calculate from the voltage swell 10%. So, we can calculate the value of 230 volt. So, since it is a DVR put on left side, must inject the voltage in quadrature with the current of the load, and we can find out VL equal to Vn. So, from this relation we will get beta equal to 43.34, and from this delta we can calculate the delta beta minus 5. So, it comes like a 6.47, and from this relation of VL sin delta V DVR sin minus beta. So, we can calculate the value of V DVR 35.64, and the voltage rating of the DVR same as this value, and current rating of DVR is the same as the load current, that is 25 ampere. So, VA rating of DVR will be your voltage rating multiplied the current rating. So, it becomes 891.15 VR, and power rate of course, the power is active power is 0. So, the total rating of your DVR will be P square plus Q square. So, it comes only Q because P is 0. So, it comes 89.15 VA. So, voltage rating of D statcom of UPQC is equal to the AC voltage, that is V D statcom equal to Vs 253 volt, since it is putting on the left side across the grid, and since connected across the PC of 253 voltage sine wave, and current rating of the D statcom of UPQC is computed as all. The D statcom UPQC is to correct the power factor of the source to unity. Hence, the required reactive power by the D statcom is now higher than the load reactive power, as angle between the supply voltage and load current is increased. So, that is beta plus delta, and D statcom current rating now is IL sin beta equal to typically 17.16, and Q of this will be voltage, that is PCC voltage multiply current. So, it becomes 41.01 VAR, and power active power is 0 because it is UPQC P. So, there is no active power required for DVR, that is why D statcom also do not have a to circulate any active power. So, V rating of D statcom will be P square Q square. So, it is QST, and that is your Vs into DST equal to this Vs into IL sin beta. So, this becomes 253 into 17.16. So, it becomes 4314 VA. Hence, the total VA rating of UPQC will be your SDVT, SDST plus SDVR, D statcom rating and plus DVR rating, that is typically sum of these two. So, it becomes 5233.13 VA like. So, hence considering the overall rating both normal and voltage swell, the rating of both compensator, we can call it voltage of D statcom 253, current 17.16. So, the SDST becomes like a typically 4314, and VDVR is 35.64 voltage rating, IDVR 25 ampere. So, it becomes like a 890.15, and so your D statcom rating is 4341 and DVR rating 891. So, total rating of UPQC is a sum of both. So, it becomes 5233.13 VA like. So, coming to numerical example 4, a single phase UPQC consisting of D statcom and DVR with the two V's common study is to be designed for a load of 230 volt 50 hertz 25.8 K lagging power factor as a right hand UPQC, and there is a voltage sag of 20% in the supply system with the base impedance of 230 volt. Calculate the voltage rating of D statcom, the current rating of D statcom, VA rating of D statcom, and the voltage rating of DVR, the current rating of DVR, and the VA rating of DVR, the total VA rating of UPQC to provide the reactive power compensation for unity power factor of AC means with constant regulator voltage of 230 volt 50 hertz across the load. So, here typically we can call it typically UPQC P with the right hand. So, we are injecting the voltage in phase with the current like you can see. So, that active power injected here. So, this active power when we are injecting, we are taking active power from D statcom. So, under sag condition we will take active power and inject here the voltage, and for swell condition we will take power and feed the voltage to this. So, these are typically waveform. You can see load voltage regulated where there is sag in this. So, this is the typically the injected voltage. In addition to this, that becomes load voltage and source current accordingly adjusted, but the load and typically the load current and typically load voltage are not affected, and that is the typical how we are injecting from under sag this voltage in phase with the current. Because power factor unity, because it is already making unity this current. So, current and voltage both are in phase as far as supply side is concerned. So, coming to numerical part of it, typically given that the Vs equal to 30 volt 50 hertz, a load of 50 230 volt 50 hertz 25 ampere 0.8 lagging power factor. So, there is a voltage sag of -20%, x equal to 0.2 in the supply system with the base value of 230 volt, and active power of the load is your typically 230 25 into 0.8 4600 watt, and during normal condition the V D statcom is 230 volt and I D statcom will be corresponding to 15 ampere. So, D statcom rating is your voltage multiply current, so it become 3450 VA. So, rating of the DVR voltage is 0, current VR rating is also, then D statcom rating is DVR rating is 0 because of nominal condition, we are not injecting any voltage, and so there is no action of the DVR, but D statcom have to still correct the power factor to unity. Now, coming to the voltage sag compensation by right hand UPQC, it means that the voltage during sag, the supply voltage reduces by 20%. So, this is the typical voltage for the your grid voltage or PCC voltage, and the current of the grid can be then power divided by this voltage. So, it becomes 25 ampere, and the D statcom rating is equal to the your 230 volt since connected across the load directly. So, the rating of the current rating of D statcom UPC is computed as that the D statcom UPC is correct the power factor of the load to unity, hence the required reactive power of the load must be supplied from the D statcom, and that comes like a 25 into 0.6 into 15 ampere, and the active power of the D statcom will be corresponding to the active power required by the your DVR, that is the power of DVR divided by 230. So, it is a 5 ampere. So, total current of the D statcom will be the reactive current plus active current. So, that comes like a typically your 15.81 from 5 ampere and 15 ampere, it becomes 15.81, and V rating of the D statcom will be the voltage multiply the current. So, it comes 3636.62, and voltage rating of DVR of UPQC is calculated directly from Vs into X. So, that is a 46 volt, and the current rating of the DVR of UPQC is same as the supply after the compensation. So, IDVR equal to IS, the fundamental active component of load current is 4600 divided by 184, that is a 25 ampere, and the V rating of DVR will be your VDVR into IDVR. So, 46 into 25 ampere, that becomes your 1150 VA, and the VA rating of the UPQC during the voltage sag is your SDST plus SDVR. So, it comes your typically 36.62 divided plus 1150, so it becomes 4786.62. Hence, considering the overall rating both normal and under voltage sag rating of both compensator, so D statcom 230 volt with 15.81 ampere. So, that is the rating of the typically of D statcom 3636.62, and DVR is compensating for 46 volt with the current of 25 ampere. So, it is a DVR rating is 1150, and the overall rating of the VF is the DST plus DVR. So, that is 36.62 plus 1150. So, it becomes 4786.62 VA. So, coming to fifth numerical example, typically a single phase UPQC consisting of D statcom and DVR using 2 VSC with common DC bus is to be designed for compensation of load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor as a left hand UPQC, and there is a voltage sag of -10% in the supply system with phase value of 230 volt. Calculate the voltage rating of DVR UPQC, current rating of DVR, VA rating of DVR, voltage rating of D statcom, current rating of the D statcom, and VA rating of D statcom, and total VA rating of UPQC to provide reactive power compensation for unity power factor to means constant regulatory voltage of 230 volt 50 hertz across the load. So, this is typically because we are putting left hand D statcom and say DVR on series on the load side. So, that is typically the phasor diagram that this is typically how we are injecting the voltage here, and these are the typical waveform. So, coming to numerical portion of it, that the Vs equal to 30 volt 50 hertz, a load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor, there is a voltage sag of -10%, and in the supply system base voltage of 230 volt. So, during normal grid condition, the VD statcom is 230 volt and current rating is corresponding to reactive power of the load. So, that is corresponding to 15 ampere, and the rating of the D statcom is your 230 into 15 3450 VA, and the rating of DVR is typically 0 because we are not injecting any voltage, and that the real and VA rating is also there. But for the voltage sag compensation by left hand UPUC, now DVR have to function for voltage injection. So, it means that during voltage sag the supply voltage reduces to Vs equal to dash Vs minus 1 x. So, 230 into 1 minus 0.1. So, it becomes the voltage typically of 207 volt in place of 230, and the active power of the load now is VLIL. So, that is 230 into 25 into 0.8 4600 watt. So, supply current during the voltage sag compensation is as a PL upon Vs dash. So, it becomes 22.22 because there is a voltage sag here. So, voltage rating of the your DVR of UPQC, the voltage sag 10%. So, typically for nominal voltage of 230 volt, therefore left hand must inject a voltage in phase with the load current to provide the required voltage. So, the from phasor diagram Vs sin delta equal to typical putting the value here. So, if you put value here, then all these, so we get the DVR equal to 29.71 and delta is 4.94 and beta comes 41. Typically 83. So, VA rating of the DVR will be 29.7 volt, and current rating of this will be same as load current rating because it is connected on the load side 25 ampere, and the VA rating typically of the your DVR UPQC is your 0 because we are only putting active power, not the reactive power. So, PDVR will be same as here. So, we put the this voltage and current. So, 742.75 watt, and SDVR will be the same as PDVR. So, that is 742.75, and voltage rating of D STATCOM of UPQC is equal to the your 230 volt, and the current rating of D STATCOM is computed as follows. So, D STATCOM UPQC to correct the power factor of AC mains to unity, hence the required reactive power by D STATCOM now higher than the load reactive power as the angle between the supply voltage and load current is change beta equal to 5 plus delta, and D STATCOM rating is as your Q equal to VLIL sin beta. So, that comes 3450 VR, and PDST equal to your typically your voltage and current. So, it becomes minus 7442.75, and the V rating of typically of now D STATCOM will be P into plus Q square. So, it becomes 3.3529 which we calculated here, and your IDST will be your SDVST will be your typically your VA divided by voltage. So, it is 17.04, and voltage rating of UPQC doing sag will be SDVR and plus SDST. So, it becomes 3529 plus 742.275. So, it says 4271.75 VA like. Hence, considering the overall rating for normal and under voltage sag, the rating of both compensator are D STATCOM 230 volt and current rating 7.07, and the D STATCOM rating is 230 into 7. So, it becomes 3921 point VA, and DVR voltage rating is 2.71 and current is 25 ampere. So, its rating comes 742.75, and total rating will be SD D STATCOM SDVR. So, adding these two, it becomes 4663.95 VA. So, coming to sixth numerical example, a single phase UPQC consisting of D STATCOM and DVR using 2 VSC with a common DC based capacitor is to be designed for compensation of load of 230 volt 50 hertz 25 ampere 0.8 lagging power factor as a left hand UPQC, and there is a voltage swell of 10% in the supply system with the base value of 230 volt. So, calculate the voltage rating of DVR, current rating of DVR, VA rating of the DVR, and voltage rating of D STATCOM, current rating of D STATCOM, and VA rating of D STATCOM, and total VA rating of UPQC P to provide reactive power compensation for unity power factor AC mains with constant regulated voltage of 230 volt 50 hertz across the load. So, this is you can again see that it is a left hand UPQC. Yeah, it is a left hand UPQC. So, D STATCOM put on the grid side and your DVR put on the load side, and this is the typically the phasor diagram referring to this condition, and this is the typically the waveform after getting the complete model and solving that. So, coming to the numerical portion of it, given that Vs equal to 230 volt 50 hertz, a load voltage of 230 volt 50 hertz of 25 ampere 0.8 lagging power factor, there is a voltage swell of 10% in the supply system with the base value of 230 volt, and the active power of the load is VLIL power factor. So, it comes like a 4600 watt, and grid current the normal operating condition is PL upon Vs. So, it is a typically 20 ampere, and during normal grid condition the injected voltage by DVR should be equal to 0, and typically the DVR current is 25 ampere, and normal grid condition the D-STATCOM current is reactive power of reactive current of the load, and voltage typically so is the same at 230. So, you have a your D-STATCOM rating 230 into 15 like. So, now coming to voltage swell condition by left hand UPQC means that after the voltage swell voltage increases. So, it is say 230 into 1.101. So, it become 253 volt, and supply current after the voltage compensation is your power divided by Vs. So, it is your current become 18.18 because the voltage increases because of voltage swell across the PCC. So, voltage rating of DVR for UPQ is computed as, since there is a voltage swell of 10% in the supply system with base voltage of 230 volt, therefore, the DVR of left hand UPQC must inject the voltage in out of the phase of load current to provide the required voltage at load end, and from the phasor diagram we can calculate the typically the voltage V sin delta equal to V DVR into sin phi. So, from which we can calculate putting the value here we can find out the typically the V DVR equal to 28.05 and the angle beta comes 33. I mean that be phi minus delta already we calculated. So, V rating of the D-STATCOM DVR is 28.05 and current rating of DVR is same as the load one, that is typically 25 ampere, and the reactive power is 0 because it is only injecting the active power the your DVR, and the power is now voltage multiply the current. So, 28.05 into 25. So, that is 701 watt, and SDVR will be the same as PDVR. So, that is 701 VA. The voltage rating of D-STATCOM UPQ is equal to the AC voltage of V D-STATCOM 253 since it is connected across the PCC of 253 sine wave. The current rating of D-STATCOM P is connected as follows. The D-STATCOM of UPQC to correct the power factor of the source to unity, hence the required reactive power by D-STATCOM is now lower than the load reactive power as the angle between supply voltage and load current is reduced to beta, which is phi minus delta. So, D-STATCOM current rating reduces to your Vs into IL sin beta. So, it is say 23 into 25 into angle of beta 33 degree. So, it becomes 3450 VAR, and power of course, DVR equal to DST because whatever power DVR needs it had to circulate through D-STATCOM. So, it comes same as 701 watt. So, V rating of the D-STATCOM will be P square plus Q square. So, this becomes 3520.5 VA, and current rating through D-STATCOM in voltage swell condition is that typically V rating divided by the voltage. So, it is a current of D-STATCOM is 13.91 ampere, and the V rating of UPQC will be your V rating of D-STATCOM plus V rating of the DVR. So, it comes totally adding these two, it becomes 4221.5 VA. Hence, the considering the overall rating both normal and under voltage, the rating of compensator are V D-STATCOM 253 volt and I D-STATCOM 15 ampere, and S D-STATCOM is multiplication of the 3795 VA, and V DVR is 28 volt, I DVR 25 ampere. So, VA rating of the DVR is 701 VA, and overall VA rating of UPQC is your D-STATCOM rating plus your DVR rating. So, it becomes 4496 VA. So, coming to the 7th numerical example, a single phase UPQC consisting of D-STATCOM DVR using 2 VSC with common DC bus capacitor is to be designed for a load compensation of 230 volt 50 Hz 25 ampere 0.8 lagging power factor as a right hand UPQC, and there is a voltage sag of 20% in the supply voltage with a base value of 230 volt. Calculate the voltage rating of DVR, current rating of DVR, V rating of DVR, voltage rating of D-STATCOM, current rating of D-STATCOM, V rating of D-STATCOM, and total rating of the UPQCS to provide the reactive power compensation for unity power factor at PCC with constant regulated voltage of 230 volt 50 Hz across the load. Consider the same V rating of both VSC. So, this is interesting, you can call it the assumption like, and why it is this, because normally the inventory of both inverter is same. So, we can load keeping the losses also same. So, it is a right hand UPQC. So, D-STATCOM on right side closer to the load, and the DVR is in series with the line which is right configuration we already discussed earlier. Now, only the method of control is different here. So, you have a supply voltage, supply current corresponding to the power, and this is the load voltage, load current, and this is the DVR injected voltage. So, that the load voltage is regulated compared to the there is a voltage sag on the typically. So, coming to the numerical portion, given that Vs equal to 230 volt 50 Hz, a load of 230 volt 50 Hz, 25 ampere 0.8 lagging power factor, there is a voltage sag of 20% in the supply system with the base value of 230 volt, and both voltage source converter are the same rating. So, this is interesting case, like because you are having equal loading of both. So, under steady state condition for unity power factor without voltage sag, the active power of the load is typically VL IL cos phi. So, it becomes like your 230 into 25.8. So, 4600 watt, and reactive power of the load is your QL equal to your typically 230 25 into 0.6. So, it is a 3450 VR. Now, the supply current typically will be your active power divided by 230, that is 20 ampere. So, each VSC reactive power rating have to be half of the reactive power of the load, so which is equal to your Q DST equal to Q DVR equal to QL by 2. So, it is a 3450 by 2. So, each you can call it compensator have a VA rating 1725 VR. So, from the following relation of reactive power of DVR, the power angle can be calculated. So, we know the Q DVR VL and sin delta. So, it is 1725. So, there delta we can calculate, and from this P DVR will be from this relation we can find out will be your 339.69. Now, the SDVR will be Q DVR plus P DVR. So, that is typically this VR, and I DVR equal to 20 ampere, and V DVR equal to now this much voltage. Once we know V rating and current rating, we can find out the voltage rating. The active power of D STATCOM is equal to same as the typically of power of DVR, that is 339.69, which we calculated earlier, and the voltage rating of the D STATCOM of UPC equal to the AC load 230 volt and is across the load of this. So, current rating of D STATCOM is computed from the angle calculation of beta equal to 5, and that is 36.87 minus 22, so 14.85. Therefore, D STATCOM current rating will be IL 1 plus cos square minus cos 2, that is the angle between the typical. So, it comes typically of 7.64 ampere, and the phase angle between the D STATCOM and current you can call it PDST is 339, which is D STATCOM need this, DVR need this power. So, D STATCOM have to supply 339.69 watt, and this can be equated to VLI D STATCOM cos. So, you get the angle for 5 D STATCOM 79.02, and Q D STATCOM we can calculate is 1725 VR. So, for after coming the voltage compensation typically by right hand UPQC. So, each VSC have a reactive power equal to half of the reactive power load, which is equal to like a QL QDST equal to QVR QL by 2, that is 1725 VR. From the relation of reactive power of DVR, the power angle is computed as typically from this relation. So, your V supply voltage reduces to 184, and with the sag of 20%, and Q DVR will be typically IS equal to that same as the DVR of the already we have given. So, we can calculate delta from here, and then once we know delta we can find out typically the even a current in the you can call it current in the supply, and the voltage rating of the you can call it of DVR can be calculated from the phase this phasor. So, it comes 77.56, and current of DVR is same as the connected in series with the supply. Therefore, it is I DVR equal to IS 25. So, V rating of the DVR can be calculated this 77.56 into 25. So, it becomes 1939.02 VA, and the active power flow through DVR will be corresponding to your SC square plus minus Q square. So, it is 885 watt, and the minus sign denotes the DVR absorbing the active power, which is fed from DC bus. Therefore, active power of the D STATCOM is minus DVR, that is 885, and voltage rating of D STATCOM is same at 230 volt, then it is connected across the load, and current rating of the D STATCOM UV is computed. So, therefore, angle between of supply voltage will be beta equal to 5 minus delta. So, it comes for 19.41, and D STATCOM current will be then IDST SDST by typically this. So, we know SDVR because both rating are equal, divided by 230. So, we get the current of 8.43. So, phase angle between D STATCOM voltage and current will be now P you know. So, from P we can find out the angle of D STATCOM 62.86, and Q DST can be calculated, that is already 1725. They are sharing equal reactive power. So, V rating of D STATCOM will be P square Q square, that comes 1939.2 VA, which confirms the solution, and V rating during the voltage sag is your SDST, that is both equal, and that comes 3878.07. Hence, considering overall rating both normal under rating of both compensator is 89 into 25, that is 2197.5, and D STATCOM 238 that comes 1939. So, total rating of this is 4136.5. So, actually both VSC are of same V rating, then the invert is same. So, SD are equal to 2197 VA, and overall rating will be of sum of both. So, that is 4395 VA like. So, coming to the example 8, a single phase UPQC consisting of D STATCOM DVR using 2 VSC with common DC link capacitor is designed for a load compensation of 230 volt 50 Hz 25 ampere 0.8 lagging power factor with the left hand UPQCS, and there is a voltage sag of 20% in the supply voltage, the base value of 230 volt, and calculate the voltage rating of D STATCOM of UPQC, current rating of UPQC, and VA rating of UPQC, the voltage rating of DVR, current rating of DVR, and VA rating of DVR, and total VA rating of UPQC to provide reactive power compensation unity power factor with constant regulator voltage of 230 volt 50 Hz across the load. Consider the rating of both VSC same. So, here what we are putting a D STATCOM on the left side and DVR on the right side. Why we are taking such numerical? Just to see the relative value with the different configuration for the same loading condition, same sag or swell conditions. So, that is typically the phasor. So, coming to numerical part, given that Vs equal to 230 volt 50 Hz, a load of 230 volt 50 Hz 25 ampere 0.8 lagging power factor, and there is voltage sag of 20% in the supply system with a base value of 230 volt, and both UPQC are of same rating. So, UPQC S operation under nominal condition is as the active power of the load is equal to VLI into PF. So, that is typically 4600 watt, and reactive power of the load is your QLVL, that is 3450 VR, and supply current will be now power divided by voltage, that is 20 ampere. So, each VSC have a reactive power equal to the half of the typically reactive power of the load, which is your typically QL upon T. So, it comes 1725 VR. From the following relation, the reactive power of D STATCOM, the power angle can be calculated. So, we know this, putting the value here of beta. So, beta comes 17.46 degree and delta comes 30 typically of 19.41 degree, which reduces the rating typically correspond to that. So, we can call it active power of D STATCOM will be equal to typically of VSIS minus VSIL cos beta. So, it comes 885.15, and current rating of D STATCOM can be calculated from as P q square under root divided by voltage. So, it comes 8.43 ampere, and angle of D STATCOM comes from this power and VA rating. So, it comes 117.22 degree, and the VA rating of this becomes like a current and voltage. So, it comes 1938.90 VA, and active power of DVR is same as the D STATCOM. So, that is we calculate. So, it is 885.15, and current rating of DVR of U is equal to the AC load defined since connected this. So, VA rating of both must be same. So, because of equal sharing of reactive power, the same power to common bus, the voltage rating of UPQC should be like your VA rating divided by current. So, it is a 77.56, and QDVR will be voltage into current. So, that comes typically putting the value 1725, and the P is same 885. So, you can calculate VA rating of DVR P square plus Q square under root of that. So, it becomes 1938.95 VA like. So, coming to the, there are two options. So, you can calculate two ways. So, coming to first method, the voltage sag compensation by left hand UPQCS, each VSC has a reactive power rating equal to the half of the reactive power of the load, which is equal to the QDST equal to 3450 by 2 1725 VR, and supply voltage under voltage sag condition is typically of 184. So, from the relation of reactive power of D STATCOM, angle can be calculated. So, that is typically 1725 VR. On solving this equation, we can calculate the beta, it comes to 22.02. So, we can calculate from delta from here. So, it comes 14.85 degree, and active power of D STATCOM is typically calculated from there. So, it comes typically the value of 335.69. The voltage rating of D STATCOM of UPQC is typically 184, because it is connected across the source, and current rating of your VA rating no. So, current rating you can calculate. So, it is a P square Q square under root that V D STATCOM. So, it typically comes 9.55 ampere, and VA rating of D STATCOM of UPQC is same as your V DST I DST. So, 184.9. So, it is 1757.36, and active power of DVR and D STATCOM same, that is 339.69. So, current rating of DVR is equal to the load current, that is 25 ampere. So, since it is connected series with the load. So, voltage rating of DVR and UPQC is computed as your SDVR upon IDVR, and it is your typically 1757.3625. So, it comes 70.29 volt, and current rating of DVR is the same as the load current, that is 25 ampere, and PDVR equal to PDST 3359, and QDVR equal to typically of 1725 from this relation, and SDVR will be like a P square Q square under root. So, 1757.36 VA, and voltage rating VA rating of UPQC will be your D STATCOM rating VA rating, and this both are equal. So, it comes 14.27 like. And second method for voltage sag compensation is by left hand VSC. It means after the sag compensation reduces to typically 230.8, so it becomes 184, and K 0 in the phasor diagram is 1.25 and 0 is 1 upon K 0.8. So, supply current after the sag composition is typically your 4600 divided by 184 25 ampere, and left hand as the each VSC reactive power rating equal to the half of the reactive power. So, that is the load reactive power by 2. So, that comes 1725 VR, and since the D STATCOM is connected across the AC mains, the voltage rating of the D STATCOM is same as the voltage rating of the D STATCOM. So, it becomes like 184, and under voltage sag from the following relation of reactive power, the power angle can be calculated typically from reactive power. So, typically beta comes to 22 and delta comes typically 14.85, and P we can calculate the power of D STATCOM from this relation, it comes 339.69, and the angle of D STATCOM is like a 78.99 degree, and the current rating of D STATCOM is calculated from P divided by voltage in cos. So, it comes 9.55, and V rating of D STATCOM is this voltage on the D STATCOM across 184 into 9.55, so it comes 1757.36, and rating of DVR is computed from common relation of DVR. So, DVR rating is P equal to PDST equal to 335969, and current rating of DVR is equal to the AC load current of 25 ampere. It connected series with the load, and voltage rating of DVR is same the V rating divided by current. So, it comes 70.29, and P is both power active power is both of D STATCOM. So, it comes 33.69, and you can calculate the SDVR QDVR equal to this much rating, and SDVR P square under root. So, it becomes 1757.36 like. So, V rating of UPQC will be your V rating of the D STATCOM and DVR. So, it is a sum of both are equal. So, it becomes 3514.27, hence considering the overall rating of normal, this rating of both compensators are typically D STATCOM voltage rating 7756 and DVR current rating 25, and the V rating is your this multiplier icon. So, it is 1.39 VA, and V D STATCOM 230 volt with the 9.5. So, it becomes like a 2196 VA, hence the both VSC share the equal at the time of minimum rating. So, you can call it as V rating of the UPQC will be ST V rating of the D STATCOM plus DVR. So, it becomes your 939 and 2196.5. So, it becomes 4135.5. So, alternatively both VSC of the same are considered. So, you can call it as D STATCOM SDVR 2197.5. So, total VA rating becomes sum of both, that is a 4393 VA like.